Hey, welcome back to Cybersphere Chronicles. There was a time when cable splicing was this super secret skill that only the best technicians could master. Imagine being the one responsible for keeping entire networks connected and running smoothly. It's like having superpowers, right? Well, today we're going to take a journey through the evolution of cable splicing, from the basic hand tools of the past to the advanced technologies we use today. We'll explore how this field has transformed and why it's more relevant than ever. If you've ever wondered what goes into making those perfect connections, this is the video for you. Let's go back to the beginning. In the early days of electrical and communication systems, cable splicing was a manual, time-consuming process. Technicians relied on basic tools like wire cutters, pliers, and a lot of patience. Every splice was done by hand, with no fancy technology to assist. The wires had to be cut and stripped perfectly, aligned with precision, and then twisted together to form a secure connection. After that, they were typically wrapped with tape or some other insulating material. You can imagine how much time this took, and how easy it was to make mistakes. One wrong move and the whole splice could fail, leading to electrical shorts or signal loss. It was a job that required both skill and a steady hand. Back then, this type of work was reserved for highly trained professionals because the margin for error was so slim. If something went wrong, it could result in significant downtime or even danger if you were working with live electrical wires. But these early techniques laid the foundation for everything we have today. They were simple but effective. As electrical systems expanded and the need for more reliable connections grew, so did the techniques and tools. One of the biggest innovations was the use of electrical tape. This might seem basic to us now, but it was a major step forward at the time. By using electrical tape, technicians could create splices that were insulated from moisture and other elements, reducing the risk of failure over time. Another huge development was soldering. Soldering involves heating a metal alloy, called solder, to join two pieces of metal. In cable splicing, this meant that technicians could make a much more secure connection by soldering wires together instead of just twisting them. Soldering created a solid, conductive bond that was far less likely to come loose or degrade. The soldering process revolutionized splicing, making it more durable and reliable. However, it wasn't without its challenges. Soldering required specialized skills and equipment, and it took time. For large-scale projects, it wasn't always the most practical solution. But despite its drawbacks, soldering helped push the industry forward and set the stage for the more advanced tools and techniques that would come later. Now, fast forward to today, and we've come a long way from those early methods. Today, cable splicing is a blend of both art and science, and the tools we use have evolved significantly. One of the most revolutionary tools we now have is the fusion splicer. These devices use heat to fuse two fiber optic cables together, creating a seamless, almost lossless connection. Fusion splicing is a complete game changer because it allows for precise, automated splicing. Instead of manually twisting wires or using solder, the fusion splicer does all the work for you. It aligns the fibers perfectly and applies just the right amount of heat to fuse them together. This results in a connection that's not only strong, but also highly reliable. And the best part? Fusion splicers have drastically reduced the chances of human error. The tools are designed to do the hard work, and they can even adjust for different environmental conditions to ensure the best splice possible. This means fewer failures, less downtime, and better performance overall. You don't need to be a master splicer to achieve professional results anymore. But even with all this new technology, there are still some basic techniques that every technician or enthusiast should know. Let's break down the most important ones. 1. Mechanical splicing. This is a quick, non-permanent method used for temporary fixes or testing. Mechanical splicing aligns the fibers and holds them in place with a small mechanical device. It's not as permanent as fusion splicing, but it gets the job done in a pinch. 2. Fusion splicing. This is the gold standard for permanent, reliable connections. As I mentioned earlier, fusion splicing uses heat to fuse fibers together, creating an incredibly strong bond. It's the go-to method for fiber optics, especially in long-distance networks. 3. Ribbon splicing. If you're dealing with multiple fibers at once, ribbon splicing is your best bet. Instead of splicing each fiber individually, you can splice a whole group of fibers simultaneously. This method is fast, efficient, and ideal for large-scale installations. These are the foundational techniques, and knowing which one to use in different situations can make all the difference in terms of efficiency and reliability. So, what's the future of cable splicing? With the rise of 5G networks, the Internet of Things, IoT, and smart cities, the demand for robust, high-performance networks is only going to grow. We're already seeing advancements in AI-powered splicing tools that can adjust settings automatically based on the type of fiber or environmental factors. Imagine a world where your splicing tools can self-correct and optimize the connection on the fly. That's the direction we're heading. As we move toward more interconnected systems, especially with fiber optics becoming the backbone of our digital infrastructure, the need for precise, reliable splicing will continue to increase. And with the technology at our disposal, the job is becoming both easier and more accessible. And there you have it, the evolution of cable splicing. How we went from manual tools and hand splicing to cutting-edge technology that does the job for us. Whether you're a seasoned pro or just curious about the world of cable splicing, the tools and techniques we've talked about today are essential for anyone working in this field. If you learned something new or found this video helpful, don't forget to like, subscribe, and hit that notification bell. This is Cybersphere Chronicles, and we'll be diving deeper into the tech world in future episodes. Thanks for watching, and until next time, stay connected.